Alfa Aesar is a leading international manufacturer, supplier, and distributor of chemicals, metals, and materials. Their products are used in a variety of research, development, and production applications. This facility is located at 30 Bond Street in the Ward Hill Industrial Park. It serves as a high-hazard storage and repack facility for flammable liquids, flammable solids, corrosive and oxidizer classified chemicals. In all, over 5,000 different chemicals are housed in the facility. The building consists of a large warehouse structure with storage areas and offices. The Haverhill Fire Department is the primary first response emergency organization. It will respond from the Bradford Street Fire Station with a response time of 4 to 5 minutes from the time an alarm is received at the station. The facility has complete fire suppression coverage throughout all areas. Systems include an AFFF foam extinguishing system for the flammable liquids storage area and wet pipe sprinkler system protection in other areas. The building is equipped with strobe and horn strobe appliances. Beacons located outside the exterior doors to each storage area indicate which space is in alarm. An annunciator is located in the main entry lobby with the graphic directory adjacent to it. The purpose of this video is to provide the viewer with an overview of the anticipated fire hazards at the facility. It gives emergency responders a detailed look of the structure, the layout of inventory, and a description of the fire suppression systems installed. Building operation and layout. Alfa Aesar has 3 facilities in Haverhill: this Bond Street facility, a Shelley Road warehouse facility, and a Neck Road facility that houses only non-classified chemicals. Operations at the Bond Street facility are primarily repackaging of materials on site from one container to another in a dedicated repack area. The Shelley Road facility expands the storage space available to Alfa Aesar and is used primarily for bulk storage of received materials. Chemicals will be received typically in pails, carboys, drums, and cartons. The building has a small office area in the front. In the rear is the loading dock for receiving and shipping. Product is separated in different rooms and areas for convenience, organization, and safety based on the type of material. These are broadly classified as corrosives, flammable liquids, oxidizers, flammable solids water reactive. The primary method for moving product around in the facility is with manually operated or electric forklifts and hand push carts. Pallets are removed from trucks backed up to one of the loading docks, through corridors, and into multi-level racks in the adjoining spaces. Material may also be stored in dedicated cabinets. Outgoing product is moved into dedicated repack areas and then onto the shipping dock at the rear of the building. Storage room layouts. Chemical storage rooms have been designed for the safe storage of specific classes of materials. Each area where chemicals will be stored or transported is separated into fire protection zones. Zones 1 and 4 are where the flammable liquids are stored, including materials classified as 1B and 1C flammable liquids. Zone 1 has a separate room for Class 1A flammable liquids. Containers are primarily U.S. Department of Transportation rated and approved to contain the product. They are generally metal, although some containers are plastic. All of the containers are non-relieving style containers consistent with the limitations and requirements. Product is located on wooden pallets arranged in a rack system and shelving system. The lowest level of storage in the rack system is a fiberglass plastic-coated material that forms an open grate floor through which any spilled liquids will fall in the event that the integrity of a container is compromised. The coated nature of the surface is intended to mitigate the formation of sparks. A concrete floor is located approximately 36 inches below the open grate floor to capture spilled liquids and any release of the AFFF extinguishing system. The racks are installed to create a space between each rack. Rack height will vary. The elevation of the top level is approximately 15 feet 4 inches above the finished open grade floor. Zones 2 and 5 are areas housing corrosives. Product in these areas are primarily stored in plastic pails, drums, and containers that vary in size from 1 to 2 ounce containers up to 55-gallon drums. It is generally located on wooden pallets arranged in a rack system or in bins within the shelving system. Rack height varies, but generally is 3 or 4 levels high, including level 1 on the concrete slab. The elevation of the top level is approximately 15 feet 4 inches above the finished floor. The shelving system goes up to 8 feet high. Corrosive base product and corrosive acid product are stored in these rooms, but are kept separated by shelving. Zone 3 is an area storing oxidizers. 65% of the normal inventory includes product that is, or is similar in nature to, almost all of the products listed as Class 1 oxidizers. 35% of the normal inventory includes product that is, or is similar in nature to, 80 to 90% of the products listed as Class 2 oxidizers. Class 3 oxidizers are not presently stored in the facility. However, should Class 3 oxidizers be placed into inventory, dedicated storage cabinets, specially constructed to house this material, will be provided. These containers are designed to be connected directly to the sprinkler system so that the higher sprinkler flow densities required for Class 3 oxidizers is limited to the storage containers rather than applied to the entire space. No Class 4 oxidizers will be held in inventory at this location. Product is primarily in the solid state and is stored in cardboard boxes, bags, and other similar smaller containers, with some product stored in 5 to 10-gallon pails. Hydrogen peroxide may be stored in plastic drums, and nitric acid is stored in 20 to 30-gallon glass carboys with plastic or styrofoam overpack. Zone 6 is an area housing flammable solids. Product stored in this area is primarily metal powders and chips stored in cans, metal pails, and drums that vary in size up to 55-gallon drums. It is restricted to materials that do not react with water or have a very low reaction if in contact with water in the liquid state. Product is generally located on wooden pallets, arranged in a rack system and shelving system. Rack height varies based on the height limitations imposed by structural and other systems, but generally is 3 or 4 levels high, including 1 level on the concrete slab. The shelving system goes up to 8 feet above the floor. The elevation of the top level is approximately 15 feet 4 inches above the finished floor. Zones 7 and 8 are the largest areas in the building. They are used for general bulk storage in liquid or solid state and shipping. Materials stored here are anticipated to be non-reactive with each other or water in the liquid state. Again, storage is generally arranged in a rack system or shelving system. These areas are also used for labeling and shipping, both domestic and international. Zone 9 is the dedicated repack area. This is where materials are repackaged to fill customer orders. Repackaging is done in hoods and then moved to a labeling area and then onto the loading dock. No product is stored in this area. Zone 10 is a cold room for storing chemicals that are better preserved at lower temperatures. Zone 11 is the office area. No chemicals are stored or repackaged in this area. Zone 12 is a special trailer used for storing water-reactive flammable solids. It is parked adjacent to the building, but is not connected directly to the building HVAC systems. It has its own safety equipment installed. Zone 13 is a trailer used for the storage of dry goods. It is attached by a walkway to the main building. No chemicals are stored in this trailer. Fire suppression systems overview. The facility has complete fire suppression coverage throughout all areas. Systems include an AFFF foam extinguishing system for the flammable liquids storage area and wet pipe sprinkler system protection in other areas. Each hazard room is self-contained with 3- and 4-hour rated walls and doors. The heating and ventilation system is state-of-the-art, allowing air changes and reacting to self-contain any room with a problem and isolating it from the rest of the facility. The flammable liquids and solids are each in explosion-proof environments with chemical-resistant materials on the floors and walls. The flammable liquids room has a 3-foot pit under an FRP post and beam framing system and FRP graded deck. The suppression system is an AFFF foam system. UV, IR, and flame detectors act as early warning in case of an incident. The building is completely diked, housing a possible 250,000 gallons of liquid. The fire alarm system in the building includes manual pull stations at exit discharge locations and top-of-stair locations, as well as any corridor areas where travel distance to an exit is 200 feet or more. Mechanical system monitoring includes duct-mounted smoke detectors to monitor supply-side ductwork of all HVAC air handlers moving more than 2,000 CFM. In some instances, this requires 2 detectors to ensure proper distances downstream from elbows, bends, and other turbulence-causing elements of the ductwork. The duct smoke detectors are provided with remote test indicator and reset buttons. These are located in corridor areas outside the space served by the associated unit and are prominently identified. The main sprinkler system and riser valves are provided with automatic monitoring of pressure, tamper, and flow status at the zone valve assembly. The mechanical, electrical, and plumbing, or MEP systems, allow the fire department to manually control the systems from an isolated control panel. From here, one can manually release smoke hatches and mechanically ventilate a room with an incident ongoing. One can also choose to do nothing and let the building's systems control the situation. The safeguards give the fire department a window of time sufficient enough so lives are not put in harm's way if a problem arises. Sprinkler system. The basis of design for the wet pipe sprinkler system is NFPA 13, with storage areas of the facility considered as ordinary hazard Group 2 occupancy and office areas considered as light hazard. This includes the corrosives, flammable solids, oxidizers, common corridor, and office administrative areas. Experiences at the Alfa Aesar Bond Street facility have resulted in the requirement to be able to control or shut off the fire protection water supply to certain portions of the facility. Accordingly, in addition to the main sprinkler shutoff valve, portions of the fire protection system are arranged to isolate certain areas. All valves are supervised by the fire alarm control panel and are normally open. Tamper and flow valves are located in or adjacent to each of the areas served by the wet pipe sprinkler system. In the specialized storage rooms, there are isolation valves for the overhead sprinklers. Failure of the heat sensing element at any sprinkler head will result in immediate sprinkler operation in the affected area. Water flow within an individual zone will initiate a fire alarm via the fire detection and alarm system. The main sprinkler system and riser valves are provided with automatic monitoring of pressure, tamper, and flow status at the zone valve assembly. If the tamper switch at any system component is activated, or if the low water pressure switch is activated, this signal will cause a trouble condition on the fire alarm control panel, and its identification will be enunciated. Outside stem and yoke valves, located outside the building on the west and south sides, allow fire personnel to shut off the sprinkler system or AFFF foam system in a particular hazard room without taking the whole building out of service. AFFF system. An aqueous film-forming foam, or AFFF system, provides coverage for the flammable liquid storage area. The AFFF tank and associated valves are located just inside the west warehouse room, adjacent to the flammable liquid storage area, Flammable Liquids 2. This facilitates shorter foam extinguishing agent release times once a system is activated. A single cache of AFFF concentrate is stored in 2 vertical tanks. It is used to supply AFFF concentrate to the flammable liquids storage areas through a dedicated alarm. Additional AFFF materials are stored next to the tank to allow a recharge of the AFFF tank. This would be used to protect the flammable liquids room in the event that normal operations can be restored to the space after a foam discharge. For example, the reloaded tank could be used to coat the interior surfaces of the space through any open foam sprinkler heads prior to sending firefighting personnel into the space after a foam release. The fire suppression system in the flammable liquids storage area is a pre-primed AFFF system. Flame detectors are located below the floor grid as well as above the floor. Heat from a developing fire will cause the release of the AFFF solution at the local area closest to the source of heat. UV-IR detectors located throughout the space will also signal the system. These serve only as an early warning device to summon emergency response personnel to the site based on a signal received from the fire alarm system. The AFFF system water supply for the flammable liquid storage space is arranged to allow the water supply to be shut off for the space with the use of outside stem and yoke valves that can be remotely operated from outside the building. These are located on the south side of the building. The test pipe for the AFFF system is on the north side by the ramp. The control panels for the AFFF equipment are located in the west warehouse, adjacent to where the AFFF tanks and valves are located. This permits access for maintenance and operation of the panel without entering the spaces served. This is designed to minimize risk to responding emergency personnel if the system must be accessed for information or reset during an emergency. Air handling system.